So I'm Casey Helgeson from HEC Paris, and this talk is based on ongoing joint work with Brian Hill. And what we're doing here is comparing some different ways that the idea of robustness is implemented in different approaches to decision making. Robustness is a common theme in responses to deep or severe uncertainty, but the idea is realized in different ways. And so we're going to look at 4 different realizations. And these are all methods that other people have talked about so far in the workshop so far, so they should be familiar, and I will more or less just remind you how they work when we get to them rather than going into a lot of detail. A quick aside, there are other surveys and comparative papers on different approaches to robustness out there in the literature already, and in particular these 2 papers actually discuss 2 of the items on our menu, InfoGap and RDM. So I just wanted to signal to those of you already in the know that we know about these and that our perspective is a bit different, and we take what we're doing to add to and complement these existing comparisons. About what that perspective is, the bigger picture goal is really to compare 2 disciplinary approaches. Rather, we're comparing these 4 methods in particular, but it's a way of getting to a comparison between these 2 disciplinary approaches. So let me tell you what those are, what we mean by these. In the first one, uncertainty I'm meaning in the same way that Jakob said the distinction between risk and uncertainty. And by theory of decision under uncertainty, I mean the construction of very rigorous mathematical models of decision making, by some by economists, some by philosophers, with some of the disciplinary sort of procedures involving things like representation theorems and axiomatizations. In the second category is a bit more miscellaneous, like field-wise. It includes parts of decision analysis, risk management, operational research, engineering safety, and reliability. But everything in 2 has sort of in common, in contrast to 1, is that there are no descriptive aims at all. It's all normative in the sense that they're just trying to help people make better decisions. And that element is present in 1 as well, but there's also a lot of descriptive aims involved in that. So the 4 methods that I had on the previous slide are really representatives of these 2 disciplinary approaches. And through comparing them, we'll compare those 2. At the top, this is a quote that I often see quoted about robustness, that robustness is insensitivity of system design to errors, random or otherwise, in the estimates of those parameters affecting design choice. If you sort of switch out system design and put in something like policy action, that's what we're thinking about. The idea that the outcome of the policy action is insensitive to some amount of errors in, for example, the way that you're predicting the future. Another important issue that is informing our thinking about robustness is coming up in the second quote, which comes from a very recent survey of methods in robust optimization. Issues of over-conservatism are paramount in robust optimization, where the uncertain parameter set over which the worst case is computed should be chosen to achieve a trade-off between system performance and protection against uncertainty, i.e. neither too small nor too large. If you read that in context, they're not really suggesting that all there is to robustness is thinking about the worst case. What I mean to highlight out of this is just the issue of having to come to some judgment about the level of conservatism involved. So in light of those ideas from those quotes, these 3 questions at the bottom, these are what we're going to ask about each of those 4 methods. If robustness is insensitivity to errors, what errors? And I'm setting this up in such a way that the answer to that question is always going to be errors and probability judgments. Second, how insensitive or how robust? So how much error do you want to be robust over? And third, sometimes it'll be hard to separate from 2, but who or what determines the answer to 2? So 2 is more like within the mechanics of this approach to decision making, what's the sort of proximate thing that sets how robust the decision is. And 3 is more like in the broader decision process, what are the inputs or judgments that ultimately determine that? So I'm going to ask and answer these about each of the 4 methods, and then at the end I'll make a few general comparative statements about the methods. There's a bit more preliminaries before that. In order to help structure the comparison between methods, I'm going to introduce a decision analysis process flowchart. And the reason I'm doing this is because I find it helpful for lining up the different methods that need to be compared so that like the right bits of one are getting compared to the right bits of the other. So we're making apples to apples comparisons. So this flowchart is going to both help make those comparisons, and it's also going to make very explicit how I'm lining them up in case you want to disagree with that alignment, because in some cases there will be more than one good way to do it. I'm assuming you can't really read that, so I've redrawn it. And this figure at the top will be with us through the whole talk, really. So I'm going to start by stepping through each of these and just making sure that we're on the same page about the terminology and in a few cases saying very briefly what textbook decision analysis does under those kind of steps so that you can see what deviations from that in the other methods. So understand objectives is just about sort of what is the decision problem, what are you trying to achieve. I think that should be pretty easy to understand, not that it's always easy to do. Decision analysis has a bunch of qualitative methods to help decision makers think through this kind of thing. I'm not going to talk about them. Identify alternatives. So this means alternative policies or actions that you might take. Also easy to understand what it is, not always easy to do. Structuring the problem. I'm going to fix what I mean by saying that the problem has been structured when you can write down a state consequence matrix. In other words, when you can write down a list of options, a state space, which may be continuous or it may be partitioned into discrete states as this one is, and you can also write down the consequences for each act in each state. Textbook decision analysis usually doesn't use this kind of picture. It uses influence diagrams or decision trees, but those are largely intertranslatable with decision matrices, and I prefer to use this picture. Modeling uncertainty means quantifying uncertainty over the state space, and the standard thing is to put a probability distribution on it. Modeling values is putting utilities, standardly putting utilities on those consequences. It may also involve modeling risk attitudes. Choosing the best alternative. Okay, so this can get particularly slippery, actually, when you're lining up the things. So I'm going to say very specifically that what I mean here is that this is the point where a decision criterion is applied. Or if that means something, if this means something different to you, it's the point where a formula is applied which evaluates how good each act is in light of the modeling of uncertainty and values that has gone before that. And the standard thing is expected utility, which I'll write like this, where the P is the probability function with respect to which utility has been, the expectation has been calculated. The last thing I have, sensitivity analysis is really important aspect of decision analysis. And the general idea of what it is that you've gone through these steps up to this point making certain assumptions. Perhaps having used point estimates for things that you're not completely sure about. So the point is to now investigate, if you change those a bit, how does that change the analysis that you've done so far? Does it change the way that your options have been ranked, for example? Here's a textbook introductory statement about it. Sensitivity analysis plays a central role in structuring and analyzing decision models and often provides valuable insights for the decision maker. Here's a really quick example. I'm not going to talk about the example, just look at the lines. Each of the lines is one of the options or actions that could be taken. We're aiming to minimize this axis. So suppose the original analysis was done by assuming this was the correct number on this axis. So that means the squares are best, then the triangles, then the circles. But now let's actually vary that and see how it might change our analysis or evaluation of the options. It's this kind of thing. It can get a lot more sophisticated than that. On the diagram, it's important to note that from doing sensitivity analysis, there are sort of two things that can happen. One is continuing along this way, which is like saying we evaluated the options based on a point estimate. We also then noted that that evaluation might change. You, decision maker, just take that into account. The other thing that can happen is looping back into a previous step of the process to having identified that some uncertainty matters, putting that, for example, back into the problem structure by adding that to the state space, quantifying uncertainty over it, feeding that back through the decision criteria. And the diagram that this was based on actually had arrows going back to all of the nodes from 1 to 5. And I agree with that. When I did that, the picture just got too hard to look at. So I've simplified it. But let's just imagine that, let's just keep in mind that you can go back to any of these.
In your setup of the two types of analysis, I'll leave it to Clem and Bob on the second type. But on the first type, I don't recognize sensitivity analysis coming in at all.
Okay.
So you said you were going to compare two. I do
Yes.
recognize in practice people doing a sensitivity analysis and using it in various informal ways. But in terms of that first categorization of formal decision theory, I don't see it showing up. So how does?
Yeah. Okay. That's. I'm really glad you made that comment. It feeds into something that I'm about to get to. But the preview of that answer is that, no, I'm just going to answer it in about 2 minutes. Okay, so moving on from sensitivity analysis, I'm actually going to add a node to this. I'm going to add in 8, which I'm calling managerial review and judgment, a term that I'm borrowing from the risk management literature. I don't think I'm substantively changing this chart by adding that. Basically, it's just explicit acknowledgement that before the end of the process, there is a real human or humans who don't slavishly follow the recommendation of a decision criteria or of an analyst. They have to exercise some responsibility to sort of look at the whole thing, understand it, judge how much they trust it, and then do something. That's implicit in the original diagram. It will just help me to have that on the page to point to. And other than that, I'm not going to say anything more about that sort of final decision stage or the implementation. Okay, so we've gotten to the first method. Maximum expected utility. And now I'm getting to Chuck's question. So, as I see it, all decision models in that first category only address these nodes. Model uncertainty, model values apply a decision criterion. So, which is to say that they don't explicitly tell you anything about how to do any of these other things. It's perfectly compatible with inserting these models into such a decision analysis process. In fact, that's sort of what decision analysis does with standard expected utility to begin with. It sticks standard expected utility theory into these middle nodes, and it does these other things around it.
Just a clarification. If I ask you what is the problem structure, you'll tell me expected utility. So it's doing number 3.
Oh, I don't mean to. By problem structure, I mean this matrix, which so far has no quantification of uncertainty on it.
Oh, okay.
So in other words, another way to say it is that decision theories are assuming that these things have been already done in some way or the other. They always have to be done. You have to have the matrix before you can apply that theory. It says just do it however you like, basically. For max-min expected utility, modeling uncertainty means a set of probability functions, which puts an interval probability on each of the states. That can also be represented as a region within a probability space. So imagine this is, for example, the parameter space of a statistical model with two adjustable parameters. As Brian discussed yesterday, you may want to interpret this as, to some degree, both modeling uncertainty and values, because you can think of it partly reflecting beliefs and partly reflecting how conservative one wants to be. Then there's also more values when it comes to putting utilities on those consequences. And then the criterion is to value each act as the worst expected utility looking across that set of functions. And that's it for that. So here are my questions. If robustness is insensitivity to errors, what errors? Errors in probability judgments. And just kind of a side note that since that set represents some agent's beliefs, the flavor of those probability judgments that it's robust over, they're the errors that the agent considers to be possible. How insensitive or robust? Well, whatever's in C, basically. It's across that set, looking across the PDFs, the functions in that set, looking at the worst case. Delving a bit deeper into that, who determines it? Short answer, whoever determines C, whoever's attitudes are being modeled in that stage. And note that, as I said before, that while the standard reading of C is the decision maker's beliefs, can also be seen to involve attitudes towards uncertainty. Okay, confidence-based decision, which is what Brian presented yesterday. Again, as an example of the same sort of model, it's still only addressing these three. So it's assuming this state consequence matrix. As far as modeling uncertainty, whereas in the last example we had a single set of distributions, here you have a nested family of sets. Call this the confidence ranking. Modeling values means putting utilities on the consequences and also determining what this cautiousness coefficient is. In other words, how are you going to look at a decision and determine which of those rings is the relevant one for that decision. Choosing the best alternative then. Here, as Brian said, you could insert within this framework any imprecise probability decision rule you like, but just to keep things simple and comparable, I'm going to plug in max-min. So, in other words, the value of an act is the worst expected utility looking across the set CI. That's one of the rings, where that ring CI is picked out from the confidence hierarchy by the agent's utilities and cautiousness coefficient. What errors? Similar answer to as before, errors in probability judgment from a best guess, where the best guess is sort of the smallest set at the bottom. And again, these are the errors that are judged possible, but now there's a graded notion of possibility at work. How robust? Again, whatever is in C sub I. The confidence rank itself prioritizes the errors that one would want to be robust over. And this can come from the person making the decision. It can come from experts. It can come from scientific assessment, whatever you prefer. And then how far down you go in the ranking to see how much robustness is going to be examined. That's determined by the utilities and cautiousness, which values come from the decision maker or from stakeholders. So it's, pulling these apart, I'm just highlighting something that Brian talked about yesterday about the possibility of cleanly separating the belief attitudes and the values attitudes. Okay, infogap. As I see it, infogap covers these parts of the decision analysis flowchart.
Maybe I should leave.
It's like the previous ones, it's assuming a state consequence matrix or something equivalent to it, although usually it's not discrete states, but there is a continuous state space. Modeling uncertainty is a nested set of regions, and that, as Yakov said in his talk, that could be in a state space, it could be inside a probability space. Just to keep things comparable, I'm going to talk about the case of applying infogap in a probability space. And it's coming from a point in the center. I realize now that I probably shouldn't have stopped drawing the rings. I should have drawn them off the edges, right? Because that's unbounded. Modeling values is putting some values on the consequences, but here's where the satisficing comes in. A critical threshold has to be supplied. In the case of infogap in a probability space, it's an expected threshold, expected value threshold. So which is like not putting numbers on all of those, but just saying which ones are above the threshold and which ones are not. Then the robustness criterion is that the value of each act, so these rings in infogap are indexed by alpha, so the value of each act is the biggest alpha such that that act guarantees you to be above critical for every distribution within that ring. So since this was just talked about, I'm going to skip through this visual demonstration. Sensitivity analysis. Okay, so what happened at 6, this was based on a fixed critical value. But like in the chart that Yakov just showed, that's followed by sensitivity analysis on this critical value that was supplied at modeling values. So you get something which looks like this, where this axis is the critical value, and this is how much robustness, and each of these lines is a different policy. So, for example, if you specified this as your critical value, the squares are the most, provide that most robustly, then the triangles, then the circles. But had you supplied a different number, and maybe you're not totally sure that that's the best one for you, then that can change the way that the acts are evaluated. If you're way down here, every time you see one crossing, that's a place where had you given a different threshold, then you might come to a different evaluation. Oops. So, okay, I'm going to stop there on this picture for now. So what errors? Errors in probability judgments in this case, from the best guess represented by a point. How insensitive or robust? Well, point A, if you're talking about what the decision criterion says, it doesn't have a set amount of robustness it wants. It's given the critical value, the more robustness, the better. Then again, when we move to sensitivity analysis, the decision maker can consider trade-offs between critical value and robustness and decide which of those curves offers the trade-off that they think is best for them. So what determines the answer to that? Well, the uncertainty model, the nested sets, that prioritizes errors to be robust over. Then the DM's critical value sets the outcome with respect to which robustness is measured. So it's the interaction of those two parts. That's happening in decision criteria. After sensitivity analysis, there's the DM making what I'm going to call an unguided judgment about which act offers the best trade-off. So it's sort of at what I'd call 8 on the basis of sensitivity analysis. Last one, RDM. And this is where this particular process line is going to get slightly strained, but I'm going to stick with it anyway and map RDM onto that. As I see it, RDM covers these bits. So it's doing sensitivity analysis like RDM, and it's also paying some attention, a lot of attention to these earlier steps 2 and 3. But to start with, I'm going to skip over to this picture, which is from an RDM publication about what RDM looks like, and briefly just remind you about what's going on in each of these things. Compared to what on my chart was called structuring the problem, this is structuring the problem, but it's only kind of a preliminary structuring of the problem. So in these problems that Rob talked about where there are very large, many-dimensional state spaces, this step is describing that many-dimensional state space and putting very wide bounds on each of the dimensions. Then there's choosing a candidate strategy. Then there's exploring the behavior of the system throughout that big parameter space and seeing where that strategy succeeds and where it fails. Here, that leads to characterizing the vulnerabilities through scenario discovery. And what I want to say about the scenario discovery in terms of mapping it back onto my chart is that it corresponds to partitioning of the state space. So this is an example from an RDM application to a water management case. So the big many-dimensional, 16-dimensional messy state space is projected down onto this one, and these few divisions are made. This is partitioning the whole space into just 3 states. It's saying, let's talk about the state space like this. You're either in this, or you're in this, or you're in the leftover catch-all. So that's like, it's like setting up a decision matrix like that. So all of this stuff corresponds, I would say, to this phase. And identifying and assessing options for ameliorating vulnerabilities, I would map, the identify part I would map onto this line, which we already have, which is coming from sensitivity analysis back to that leading you to think through what other alternatives you might be available and might be worth thinking about. The other one, I've introduced an extra arrow here, which is more like going straight from seeing the vulnerabilities without going through a lot of assessment to thinking of new options to put onto the menu. And packed into this word assess is the whole rest of this line, I think. And that's the part that I'm really going to focus on now, because that's what's comparable to the other methods that came before. I want to recognize that that's slightly unfair to RDM. Not that I'm saying anything untrue about it, but I'm giving a lot of emphasis to the bits that are clearly underemphasized in their own depiction of the process. It's just that what's going on here is harder to compare to what those other methods are doing. Dave, how am I doing on time? 15 minutes, okay. As far as this assessment leg, there are a variety of different ways of assessing options that have been discussed in RDM publications or used in RDM applications. I'm going to mention 2 of those only, and I'm really only going to talk about one. Very briefly, the only reason I'm putting this one here is to point out that as far as mapping things onto the decision analysis flowchart, this way of assessing options is like InfoGap. Not that the criterion is like the InfoGap criterion. This is really more like, it's more like max-min, but it's like InfoGap in the sense that first here there's a criterion which is encoding some respect for robustness, which is then followed up by a sensitivity analysis that looks across changes in one of the inputs to that formula. So let me instead say a bit more about B. B is coming from this notion of running the analysis backwards, or asking how probable a given scenario must be before one act becomes better than another, where better means higher expected value. That's in contrast to saying, what's your probability? In that case, this option has the highest expected value. And I take it that the decision criterion, or the way of evaluating options there, is simply normal expected utility. sorry, I should say value. I have a V there just to be sort of neutral about how you're calculating it. It could be expected value for a full sort of utility function. It could be a dichotomized utility function. It could be regret. As I see it, when this one is used, that is also followed by sensitivity analysis. For example, in this case, again, with these 3 states, with just 3 states, you can represent all possible probability distributions over those states on a triangle. So this is a probability space. And these sort of funny looking things, 2-10, 1-10, those are actually the names of policies. And what these areas are, these are called the policy regions, which is to say that among the policies that are on the table, if your probability function is anywhere in this, then this act is the best. If your probability function is anywhere in here, then this other act is the best. Do I want to? No. I'll come back to it. Okay, so asking these questions just about the running the analysis backwards way of assessing options. What errors? It's errors in probability judgments. How sensitive or robust? If you're talking about the decision criterion itself, the way of calculating the value of options, there's no robustness built into that. It's just expected utility. You have to wait till you get to the next phase, sensitivity analysis, where you get these plots showing dependency of policy evaluation on the probability judgments, which provide a basis for incorporating a concern for robustness. But it's not giving you a rule telling you exactly how much robustness you want or you should want, or how to trade that off with other concerns. Who or what determines the answer to how robust? Since it's not in the criteria, the decision maker is making an unguided judgment based on the sensitivity analysis, based on these policy regions or expected value or regret plots. So here, on the basis of that, here are the comparative statements that I want to make. Did I miss a card?
No.
10?
No.
Okay,
About 12 minutes.
great. Decision theory implements robustness in 6, encoded within a rule. And it does that based on explicit modeling of uncertainty and values at 4 and 5. That's the bit that it regulates. Decision support, in these examples at least, implements robustness in both 6 and 7. In the cases of InfoGap and RDM with that sort of first weighted rule that I just very briefly glossed. Or in the case of RDM with the running the analysis backwards assessment method, it's all in 7.
Explain again, what is the difference between DT and DS?
Well, basically, DT is Max-Min expected utility and Brian's confidence model. And you mean beyond this answer that I'm giving you?
What does decision theory mean as opposed to this? One is normative and one is prescriptive, or what? Distinction between theory and support.
Right. I don't think I have a super clean definition, but what when I look at the fields, I see a sort of division of who is working with who and where things are published, and in terms of professional societies and whatnot. So decision theory are these models that are developed with a concern for representation theorems and for axiomatizations. There's descriptive aims, but there's also normative aims. And decision support is this broader category that I take to include RDM and InfoGap. So I understand the full name of InfoGap is Information Gap Decision Theory, but as far as the distinction that I'm making, I think it falls in decision support.
I thought you had made it in your presentation. that in both the infogap and the RDM, there's this later phase of what you call unguided
Yes.
stuff.
Yes.
And that's what I think of as decisions. The unguided stuff I think of as the decision support, whereas the decision theory, once you've set up the problem, there's a full algorithm and it gives you gives you an answer. And the answer may differ depending on which theory, but it gives you an answer. Whereas you left in the kind of informal, the way that you do sensitivity analysis, all these loops backwards. How many times do you loop backwards? You could go on. What's the stopping rule? All of that stuff was left unstated and unguided. And I don't know whether Yaakov or Rob, whether they feel the same way, but when I look at these different literatures, that seems to be characteristic of the decision support, because the human is playing a role that isn't explicit in the theory. Is that?
Yeah, no, exactly, yeah.
Yeah.
Yeah, I mean, the decision support is... Yeah, I mean, the issue of decision support is to bring analytics into human decision processes where humans are still are part of the process, and it's not just a description of what they should do. I'm going to use description twice, but it's not a description of what humans do or a normative statement of what they should do, but it's rather a inserting of the analytics into their process, when then outside of that you can evaluate whether it was an effective decision process.
Yeah, I would agree with that. My question was, does he agree with that? Is that what he means?
Having laid it out, he can answer.
Is that what you mean?
Yes. Yeah, that's what I mean. That's what I mean. I understand you being a bit frustrated about it, because in a way I'm kind of working through this towards a sort of clearer picture of what the difference is.
Good. Fine. I just meant a clarification. Thank you.
Right. Okay, so the third point here, addressing robustness, at least in part in 7, which decision support does, goes along with less modeling of uncertainty and values at 4 and 5. Or maybe less modeling of those is not quite the right term, but something like taking that modeling less seriously, in the sense that you may be modeling those things there, but with the knowledge that when we get here, we're going to revisit that and sort of challenge those things and think about other ways that those might have been modeled. 2 of 3 for discussion points. Different decision support approaches use different divisions between modeling uncertainty and values at 4 and 5 versus allowing the decision maker to exercise those attitudes in a less structured way at 8 on the basis of what's been revealed in the sensitivity analysis at 7. This feature may complicate a clean division of uncertainty assessment and values where such a separation is appropriate. So such a separation is not always even possible in these representations, but where it is, allowing attitudes to come back in over here may complicate that. What I mean is that if, for example, you think that the values ought to be coming from stakeholders, and or you think that modeling uncertainty ought to be coming from expert assessment, then allowing and encouraging and facilitating the decision makers' attitudes to come in and sort of modulate that and override that here will complicate the clean division if that's something that matters to you. Last point, I think it's implicit in decision theory that when embedding decision theories into this kind of process, the uncertainties revealed to be relevant here should always be folded back into the problem structure or the modeling by the iterative loops. In other words, whenever you realize there's something that you're uncertain about and it does affect the outcome of your analysis, well, okay, go back, because all uncertainty ought to be modeled here, and you should give it to the decision criteria to sort out. So if you discover some that you hadn't yet addressed, you should always loop back and add it in and get a better answer from your decision criterion. as opposed to doing that sensitivity analysis and not looping back, leaving it as just a sort of qualification on top of what the decision criterion offered, and leaving the decision maker in a less structured way to sort out what they think about that. Thanks. Final one, the sort of other side of that, implicit in decision support, and I'm sort of trying to start a fight. The decision model can't be trusted to handle all uncertainties. I'll leave you with that. You can ask about it. Thanks. Well, if you disagreed with that, then you would loop back, you would quantify those uncertainties, and you would give them to the rule to handle.
No, I think a good example of that would be whether a given decision model, say info gap.
A good example of the second dot there would be, can InfoGap or RDM deal with strictly qualitative uncertainties, as I mentioned at the end of my talk. You're not able to represent mathematically the sociological impact of new technology in a primitive society. Can you still do InfoGap? That's a question. I think I have an answer, but whether one can really handle strictly qualitative uncertainties in this sort of analysis, that's an open question.
I would say that is, I'm not sure that's an example of what I mean to be talking about at the second point. So those uncertainties within InfoGap are modeled in I should use this again, in the form of an InfoGap model. But then what I take it is happening at 7 is that the decision maker in an unstructured way is thinking about trade-offs between critical value and that uncertainty. So I'm tempted to say that's what's being shown in the sensitivity analysis is uncertainty about what critical value you need.
Okay, are we discussing this now?
Yes.
I think we should say thank you to I meant to go straight on.
So I don't want to give a generic answer, but, and maybe we will have an opportunity to just sit down and talk, but certainly one thing that is, that drew my attention is that your conception of InfoGap uncertainties is more limited than mine, so that there are probably 30 examples of InfoGap applications in which the performance requirement is InfoGapped. Okay? We don't know the critical value, and we include the critical value in the InfoGap model of uncertainty. There are dozens of examples like that.
Okay.
Which is part of the broader issue that I have. I really liked your presentation. I didn't faint or leave. There were moments, but also, as I showed in my example in my talk before yours, you don't have to have uncertainty only in PDFs. You can have uncertainty in other functions.
Yes.
You can have uncertainty, if I go back to Wald's min-max, Wald was uncertain about a set of PDFs. You can InfoGap, and there are examples of this, InfoGap a set of functions. So that what you're uncertain about is, did Wald choose the right set, or should there be some other set? That is, what you're InfoGapping is a set of functions.
I see.
Which, in Wald's case, would be a set of probability functions, but you could have a set of stress-strain curves.
So there's at least 2 ways to apply it in a probability space.
Right, and even not in a probability space.
Sure.
There are many, many other things that you can model with an InfoGap model of uncertainty.
Can I just ask a quick clarifying question? So when you said that you InfoGap the critical value, does that mean that there is a sort of, for lack of a better word, a state space that includes dimensions that are normal, that are part of the design, and then there are other dimensions that are the critical value, and you're InfoGapping on that whole space?
Right, and in response to an earlier question in my talk, I said, well, you may impose a limitation on not exceeding your budget. So I'm the president of Lockheed, and I think I can get away with exceeding my budget by 300%, but I'm not sure. Maybe I could get away by exceeding the budget by 500%. So my InfoGap is, how much will Congress allow me to exceed my budget? 300%, 400%, 700%. I'm uncertain about my critical value, and I InfoGap that critical value.
Sorry, one more. But you,
Not me.
Yes.
But you do always leave some evaluation of trade-offs to the decision maker, how they set that trade-off is unregulated. There's no criterion that tells them how to do it.
Right. That's the decision support part.
Okay.
He deliberates about that.
Okay.
Okay.
That's right.
I just wanted to get I understood you, Jakob. After you've infogapped the criterion, how do you define your decision after you've infogapped the threshold, whatever that criterion? How do you define your robustness function? Do you need another threshold?
No. You just
Because
the answer is really very simple. It looks confusing to you because
because the version I read, it required another threshold on top of that.
No.
Maybe.
It just you require that your budget not exceed your threshold. You think the threshold is 300%, and you're unsure. Maybe the threshold could be 400 or 500.
But you're trying to maximize the robustness given a threshold.
It really does work. It's hard to do it in your head,
Okay.
but it really does work. There are many examples of that.
Okay.
I see the main goal in your presentation or comparison is in the terms of this flow chart, the kind of more narrow, maybe sharper focus of the decision theory and the broader and looped iterative focus of decision analysis or decision support. Now, you use as a bracketing, as a kind of cover term for the problem robustness. And I think that's a bit problematic actually, as a kind of generic term for the decision criterion. On one hand, of course, there are two kind of oppositions that may be relevant. One is kind of robustness or conservatism versus aspiration on one hand, and I think a more subtle but maybe as important one is a contrast between robustness and, let's say, caution or ambiguity aversion. So one thing focuses on bad states and the bad outcomes and the avoidance of bad outcomes. The other one, robustness, would try to be achieve some kind of uniform level of performance relative to what you could have done. So to give an example of just that, it's not just words in the climate change scenario where you have kind of vague, ambiguous tales of bad scenarios. The ambiguity averse or cautious would basically put the maximum weight within the set of probabilities on the most pessimistic states. It would be the most pessimistic prior, while the a robust decision criterion would try to use something in the range, in the middle of the range of the set of priors, which is in a way good, is reasonably good from the perspective of any of the ones you have admitted. So I think these are quite different concepts. They have not been adequately discussed in the decision theory literature, but I think it would be from that point of view, it would be a bad thing to use it as just a generic heading to kind of camouflage these differences.
Sorry, can you say the name of the first one again? Just, I understood the concept, but I forgot the label you were putting on it.
Well, robustness versus ambiguity aversion, and robustness versus or caution, and robustness versus aspiration or something like that, entrepreneurship.
Okay, yeah, I accept that I'm lumping some things together under a pretty broad notion of robustness here, and it could help to clarify that, but I don't have more to say about it at the moment.
I just on. Was that the Australian thing? So the.
Which finger?
What I thought Klaus was describing in terms of different formal notions of robustness, you wanted something that works uniformly well, was that the first one I thought you were describing maximin, and the second was min-max regret.
That would be paradigm example.
And so then it would be formalized within decision theory.
Yes, it
Yes,
would be
that-
formalized, but it's not, really there's no established distinction. So
Yeah, no, I agree. There's a problem with this word robust, which everyone likes. It's a good word, but then it gets used in. But I have to just, since I got this thing, just on Yaakov. I don't understand Yaakov's. I don't want to start a fight, but I don't understand Yaakov's view that that when we talk about robustness or whatever, everybody else except for you is talking only about sets of distributions, whereas you're talking about sets of functions. I don't understand that because a standard maximin is over abstract states of nature, and a standard minimax or regret is over abstract states of nature. There's nothing specific to probability distributions, and I would say in most of the work that I do, I'm doing minimax, regret, or maximin over some function space, and not over. And I don't use the word info gap. So
You and I agree.
Can we
Yeah.
can we maybe leave that to coffee or indeed questions later? Because we're already running a bit over, and I think you should get Rob the last. 'Cause he's had his hand up.
Oh, yeah, okay, great. Well, first off, thanks for doing these systematic comparisons, which I think are really important. So that said, here's a couple of layers of critiques. First, on the info gap and RDM, I mean, I really don't. I have questions about the way you stated the errors, and maybe what I'm thinking of as errors.
The arrows?
The errors.
Okay.
The errors, yeah. And I think in both infogap and RDM, there's errors potentially implicit in the starting point, okay? Because Yakov starts with the optimum and basically nests his sets from there.
Okay.
And so it privileges a particular point in the space, at least the way I
Yes.
understand it. And then RDM has this starting point of different policies or policies. And there's a question of whether there's a path dependence as you go through an iterative process. When we've tested it, there hasn't been, but we've not tested it very often, so it's a very sparse sample in a very large space. And I personally don't understand what conditions would lead to a path dependence in the starting point that we've got. I think I understand a little bit about what I think is the starting point, you know, path dependence, or the starting point that Yakov's got. So I think you haven't really understood the errors appropriate. RDM has this other potential error in the interaction between the bounds, which don't make a difference in where the threshold between a policy working and don't working is, but how the categorization algorithms function on a large space. And if you know, they have some dependence on the bounds, and you have to be a little bit careful about that. So that's sort of a lower level.
Sorry, can I paraphrase to make sure I
Yeah,
understand
yeah.
one of those? Okay, the second one I didn't quite get, but we can talk about
Yeah,
it.
that's
The first one, so do I understand that you're saying, you're sort of viewing RDM as, to put it very crudely, kind of a search method for good policy options?
yes.
And you're saying that the result of finding a good option is robust to what options you start with on the menu.
Yeah, and the process of searching.
Okay.
Yeah, and are there big dichotomies either in where you start or how you do the search process that would lead you to very different states? Or is it mostly, you'd like it to be, the end of the search to be basically dependent on the information content and the resources you have to work through it? Sort of another level critique is it you know, in the focus on the choice part, I mean, it eliminates, I think, the notion, I think both in InfoGap and RDM, trying to find solutions, the search through solution space to find things with a relatively independent of your uncertainty. A little bit more so, I think, in RDM, that's a goal than the way InfoGap's set up, but which is meant to make the, you know, the focus on the decision criteria less important, because you're trying to come up with something dominant by creativity in solution space.
Okay.
Yeah, and then clarity in what you're purposely leaving out. So the information product's a little bit different. You know, the boundaries of where my dominant solution works and what I'm choosing to ignore. And then finally, sort of the meta is that, and this is the decision support versus decision theory, is this is evaluating based only on inputs versus on outputs. And part of the claim of coming into a decision support process with something that doesn't focus on agreement on assumptions or problem framing at the beginning is that it avoids hang-ups in contentious, you know, wicked problems. And you're not capturing any of the, you know, what happens when you bring this nice structure into a contentious environment. And, you know, so here where you say that there's and this is mostly in this part, the last part, decision models can't be trusted to handle all the uncertainties, though one thing that you often see, you know, when you bring in a, you know, decision theoretically nice structure is that people want to maintain the decision the nice structure, so they avoid all the things that might blow up the sensitivity analysis. And you weed all the, it's uncertainty absorption as you run through the process. The analysts write a 1,000-page report, and then it goes up to the managers, and they've got a short summary, and by the time it gets to the point of decision, all the caveats are gone. And that some ways of framing the decision analytics and the analysis, or more, the claim is, are more prone to uncertainty absorption than others. And so properly is, which is obviously much bigger than the resources you have to do this, is you would do the bake-off, right, where you would take different methods of teeing up problems. You would run them through identical political agencies and political processes and see which ones did a better job at the end of reaching a implemental societal decision in the face of all the uncertainty. Now, obviously, you can't do that, but you might think a little bit about how you would at least think about output measures as opposed to inputs. So that's my very long non-question.
Sorry, just to make sure I understood about output measures, you mean by output measures, you mean measures of the success of the whole decision-making process?